Hello everyone, welcome to BYJU'S exam prep. Hope you guys are fine. So guys, join the session fast. Be fast. Okay, so I'm watching how many people have joined. Let's be quick guys. Let's be quick. Okay, so we have to start with the session. So if we'll be quick, we'll start it as early as possible. Okay, join it fast. Hi Amana. Okay, okay, fine. So guys, share the session with maximum of your friends so that everybody can take benefit from it. And so we'll be starting with last 5 years PYQs. Yesterday's session we dealt with raw water and solid waste management. Two of the questions I gave you homework, so let's check it out whether you have done it or not at the end. But before that, let's start with wastewater and air pollution. So guys, everybody ready? Come on guys, be fast. Faster, faster, faster. Let's be quick. Let's be quick, everybody. Okay, so we got it. Good evening, Arun. Good evening, everybody. Okay, so let's start the session then without wasting time. I guess we have got people who wanted to study. Okay, so if you don't know about me, you can go through my profile, Fast and Furious, for further upcoming classes and all. You can join my Telegram group for the same. Okay, and last but not the least, if you're preparing for GATE and you want to have access to a number of more questions, so GATE preparation free ebook link is in the description. You guys can download the book. Okay, thanks for guidance. Welcome, Arun. Welcome, dear. Okay, so let's start with the session, guys. ये wires को थोड़ा मैं side कर दूँ. Okay. Now let's start with the session. We'll try. पहले बता दूँ. Right now it's 9. We have around 24-25 questions. So half a part we dealt it yesterday because I wanted to separate raw water, solid waste management, air pollution, wastewater. So I gave you two questions homework yesterday. So if you are not able to solve, we'll deal that also. Welcome to the topper. Arun was not the topper today, but yeah, he was above you. Yeah. So topper didn't came. Swapnil said he'll come. Okay. Guys, we are having AFRI classes also every day. Like I'm just telling you, I take AFRI classes every day at 10 a.m. So right now we have, means I'm taking a series of Prayas series. So in that we have poll questions. So Arun, Yamuna, and a number of more people, Swapnil, and there are more students which are there. So every time we have poll questions. So in the app classes, free app classes, it is free of cost. So we come to know that who is answering more number of questions and what is the score. So 20 questions each day, and we try. Sometimes it gets extended if somebody asks us to deal a particular topic. Otherwise, we have a target that to complete 20 questions in 30-40 minutes maximum. Okay, so and we enjoy that. Yes, Yamuna and everybody. So let's start, guys. Okay. Let's take a target that maximum today also we'll do it in 1 hour to 1.5 hours. Okay, which one of the following is a secondary pollutant? So when two or more primary pollutants combine, or if like sunlight and all comes into actions, so what we get secondary pollutants. So out of this, what is the secondary pollutant? This is carbon monoxide, CO, hydrocarbon, HC, ozone, O3, and the last one is volatile organic carbon, C. Everybody knows it. And you know what? This is so common question, but every year you will see, not only preparing for GATE, if you are preparing for ESE, if you are preparing for any other examination, which of the following is a secondary pollutant, which of the following is a primary pollutant, identify which is the not a secondary pollutant, identify which is not a primary pollutant. So every time they ask you, so what I'll advise you, that make sure that you should know the examples of primary pollutant and secondary pollutant. Okay, that is important. So what I tell you, just do that also. Okay, coming to the next question. Which one of the following? So it was for set 1 and set 2. Excuse me. Set 1 they have asked regarding secondary pollutant. Set 2 same here they asked for primary air pollutant. So which one of the following contains only primary air pollutant? So here it is O3 peroxyl acetyl nitrate. This is hydrocarbons O3. Only means both the things should have what? Primary air pollutants. This is hydrocarbons and nitrogen oxides. This is nitrogen oxides and then peroxyl acetyl nitrate. What it will be there? Hydrocarbons and nitrogen oxides. Remember, oxides of nitrogen, if it is nitrogen oxide, dioxide, whatsoever, oxides of nitrogen, oxides of sulfur, hydrocarbons, these all are what? These are primary air pollutant. These are primary air pollutant. Got this? Okay, correct. Okay. Now, coming to the next question. And guys, if possible, try to give yourself marks also. So 1 marks for this question, 1 marks for this question. If you have done both of them correct, 1 marks for each. So that at the end you will be telling me, you will be only totaling and you will be telling me, ma'am, how much marks we got. So it helps us to analyze ourselves in a better manner. Okay, and if you do it wrong, okay, if what you have thought is wrong, then give a negative marking as well. Because for MCQ questions, 1 marks, 1/3 is negative, 2 marks, 2/3 is negative. Okay, so give that also. Come on. Now we got a question from air pollution. A sample of air analyzed at 0 degrees Celsius, temperature is given to us as 0 degrees Celsius, that means 273 Kelvin, right? And 1 atmospheric pressure, so pressure is 1 atmospheric, is reported to contain 0.02 ppm of nitrogen oxide. Okay. Molecular mass of nitrogen oxide is given to you 46. Volume at 0 degrees Celsius and 1 atmospheric pressure is given to you 22.4 liters per mole. In case if they wouldn't have given you the volume, you should know by default. This is this. Inka bhala hai. They are good that they are giving you the volume. But in case if they don't mention you the volume, you know at standard temperature and pressure condition. Temperature standard is 0 degrees Celsius. Pressure is 1 atmosphere. At this particular condition, the volume which you get is 22.4 liters. So if they wouldn't have mentioned, then also the volume would have been 22.4 liters because it is a standard temperature pressure condition. Now, the equivalent NO2 concentration in microgram per meter cube. This you have to calculate. How will you do that, guys? How will you do it? How will you do it? See, if you remember when we talked about turbidity and all, the reason for separating raw water and wastewater, if you remember when we dealt questions with turbidity and all, that time what happened, we used to say mg per liter, ppm, they both are same. That was for the case of water. But when you talk about air, you cannot say that. You cannot say ppm and mg per liter. There is nothing to do here. Okay. If in case of air, you talk about 1 ppm, because 1 ppm it is talking about, so we'll say 1 part of anything divided by 10 raised to power 6 parts of any other thing. So what is the meaning of 1 ppm? First I'm trying to say that only to you. If you know it, then you can start with the question. 1 part of anything divided by 10 raised to power 6 part of any other thing. Okay. Now, for us, 1 part will be of nitrogen dioxide, because in a large volume of air, there will be a certain amount of nitrogen dioxide will be present. Yes. So what we'll be having? 1 meter cube of NO2 divided by 10 raised to power 6 meter cube of air. Got it? Now I have to calculate 1 meter cube of NO2 corresponds to how much microgram. That is the only thing. मुझे पता करना है कि 1 मीटर क्यूब NO2 में कितना माइक्रोग्राम होता है. ठीक है? That I want to calculate. So how will you calculate, guys? How will you calculate? Tell me fast. Now see, standard temperature pressure condition. Now check it out. At standard temperature pressure condition, which is 22.4 liters. स्टैंडर्ड टेम्परेचर प्रेशर कंडीशन जब 22.4 लीटर्स थी, जब 22.4 लीटर्स है, उस केस में भाई साहब वॉल्यूम आपको पता है, वेट भी आपको क्वेश्चन में दिया है. अब मैं आपको करके बताती हूँ. देखो, 22.4 liters of NO2 corresponds to how much molecular weight? 46 grams. So how much it is asking in the question? 10 raised to power 6 मीटर क्यूब में कितना होगा? ठीक है, या आप ये बता दो कि भाई 1 मीटर क्यूब ऑफ NO, 10 raised to power 6 meter cube is for air. So 22.4 liters condition में if 46 grams is the amount of NO2, so in 1 meter cube मतलब 1000 liters, so in 1000 liters volume में कितना NO2 होगा? How much NO2 will be there? So 46 into 1000 divided by 22.4. Come on, Arun, calculate, and everybody else, Yamuna, Rahul, everybody, Akshata, calculate how much it is coming. How many grams? Because volume of 1 mole, 1 mole कितना of NO2 कितना volume occupy करता है? Volume of 1 mole of NO2 question में given है 22.4 liters. अगर 22.4 liters consist of 46 grams, so 1 meter cube यानी कि 1000 liter will consist of how many grams? Come on guys, 2053.57. Okay, Rahul, 2053.57 grams. This much will be the NO2. Okay, now if you talk about 1 ppm, अब इसी को लिखेंगे 1 ppm is equal to, अभी क्या बोला था, 1 meter cube of NO2 divided by 10 raised to power 6 meter cube of air. ठीक है, 1 meter cube of NO2 की जगह what we can write? We can write 2053.57 grams divided by 10 raised to power 6 meter cube of air. Correct? Can we write like this? Can we write like this? If you want to convert gram into microgram, 1 gram is equal to 10 raised to power 6 microgram. So if I want to convert gram into microgram, what I'll do? I'll multiply by 10 raised to power 6. It will get converted to microgram. So from here what I'll get? I will get 2053, because 10 raised to power 6 in denominator and numerator will get cancelled out, microgram per meter. This will be the value of 1 ppm. But in the question, is it asking me for 1 ppm? No. 1 ppm, if you want to report the concentration of NO2 for 1 ppm of NO2, 2053.57 microgram per meter cube. But in the question, it is asking for 0.02 ppm. So for 0.02 ppm, how much it will be? Just multiply by 0.02 ppm, 2053.57. 41.07, correct. So 41.07 microgram per meter. Correct up to 2 decimal places. So 41.07. Got it? Now some key points which I am telling you. Number first, if they are telling you, if they haven't mentioned 0 degrees Celsius for atmospheric pressure, but in the question instead of mentioning this, they write STP. So this is the short form and it is the official form. It is the meaning of standard temperature pressure. By default, you will take the volume as 22.1 liters. Volume of 1 mole of NO2 हो, volume of 1 mole of SO2 हो, दुनिया का कोई भी compound हो, any compound, the volume of 1 mole of that compound at standard temperature pressure condition is 22.4 liters. तो ये तो किसी भी compound के लिए fixed है. Okay? Molecular weight will change. If it is NO2, the molecular weight will be different. If it is SO2, the molecular weight will be different. So that you should know, guys. Clear? So that is an important thing which you guys should know. Got it? बस बाकी कुछ नहीं है इस क्वेश्चन में. Remember, when you do it in the case of water, you take 1 ppm and 1 mg per liter as the same for all those calculations. But this is not valid in the case of air. So don't ever do that. So all the statutory warnings I have given you. Come on. Next question. This question. Come on, guys. Consider the reactor shown in the figure. So this is a reactor which is shown in the figure. The discharge is given to you in meter cube per hour. Generally, we have the habit of writing it in meter cube per second and meter cube per day. So wherever you see meter cube per hour, be extra cautious. The concentration in mg per liter of a compound in the influent and effluent. So influent concentration of any compound. You don't know whether it can be BOD, it can be suspended solids, it can be anything. They have not mentioned right now. Okay, that is C naught, and the one which is going out is C. The compound is degraded in the reactor following the first order reaction. If anybody does not know what is the meaning of first order reaction, basically you would have studied this in your mathematics. I'll tell you, first order reaction means, or first order kinetic means, rate of change of parameter is directly proportional to the parameter. Let us suppose if your parameter is organic matter. Okay, so rate of change of organic matter is directly proportional to organic matter. If your parameter is microorganisms, so rate of change of microorganisms is directly proportional to that of microorganisms. So this is the meaning of first order reaction. Now, the mixing condition of the reactor can be varied such that reactor becomes either a complete mixed flow reactor or a plug flow reactor. The length of the reactor can be adjusted in these two. So for length of complete mix, they have written LCMFR, and length for plug flow, they have written PFR. Okay, everything is cross section and all is constant, means A is constant. They're asking you to calculate the length of complete mix to that of plug flow. Now let me tell you first the difference between complete mix and plug flow. When you talk about complete mix, there you do homogeneous mixing. Okay, plug flow, you don't apply your brain. There is a large tank, water will keep on flowing from one end to the other end. Since the velocity is less and the length of the tank is more, obviously whatsoever organic matter is there, microorganisms will carry out the decomposition. Why? Because from moving from one length to other length, you are giving more time for the microorganisms to carry out the decomposition of organic matter. One more thing, this can be asked in statement wise question. If the discharge is up to 25 million per liters, MLD, million liters per day, you go for complete mix process. If the discharge is more than that, so the amount of water to be treated is more than that, you go for plug flow reactor. The basic reason is because you have to induce homogeneous mixing, and that takes supply of electrical supply, supplying oxygen, and it takes a lot of more work. Okay, and homogeneous mixing is not possible for a large amount of water. So up to 20-25 mld, you go for complete mixed flow reactor. More, than you go for plug flow reactor. Okay. Now, when you talk about here in the question, it has given you complete mixed flow reactor and plug flow reactor. If you talk about activated sludge process, instead of writing reactor, they talk about the process. So you might have already heard complete mixed process and plug flow process. Plug flow process in examination, instead of giving plug flow process, if they write conventional process, conventional activated sludge process, don't get confused, it is talking about plug flow process only. Okay, so don't get confused by that. Now, coming further, if you talk about complete mixed flow reactor, it is given in the question. So actually, this will be C is equal to C naught 1 plus KT. They have done nothing. What we used to take LT, they have taken C. What we used to take L naught, they have taken C naught. They have changed the denotions. Rather than that, everything is same. So C by C naught, they have already given to us 1 upon 1 plus KT. This formula you get it for complete mixed flow reactor. So C by C naught, I already know how much it is, 0.8. K is given to me in the question, right? Where is K? Is it given to me in the question? Just check it out whether K is given to me in the question, yes or no? Concentration, plug flow reactor, no, nothing is given. Fine. KT. This is first equation. Then talking about the next one, we have what? We have plug flow reactor. Plug flow reactor, you know, the basic conventional one. Here the basic conventional one. What is the basic conventional one, guys? What is the basic conventional one? LT is equal to L naught e to the power minus KT. So in place of LT, C naught e to the power minus KT. So here C by C naught is 0.8 e to the power minus KT. Okay. Yes, this has been given, right? Here time is for complete mixed flow reactor. Here time is for plug flow reactor. Got it. Now what can happen? Can I calculate time from here? Can I calculate time? If I take log on both the sides, log 0.8, and here I will get minus KT PFR log base E. So log base E will be 1. So from here the value of plug flow reactor which I'll get, log minus log 0.8 will be how much? Minus log 0.8. 0.22314. So 0.2314 divided by K. This will be the value of time in plug flow reactor. What will be the value of time in complete mixed flow reactor? 1 upon 0.8, 1 divided by 0.8, okay, then minus 1. So I'll get 0.25 divided by K. I got the time for complete mixed flow reactor also. I got the time for plug flow reactor also. Volume by discharge gives time. So that I'll be doing it now. Wait, I don't need those things. I'll tell you. I got the time in both the conditions. Okay, if you go by volume is equal to discharge into time, if you are doing it, volume is equal to discharge into time, and you're calculating time from there. But you are not using this expression. Where will you use this expression, Yamuna? Because we know the time for plug flow reactor and complete mixed flow reactor will be different for sure, because in complete mixing is being done, while in plug flow no mixing is being done. That is a conventional process. Okay, now it is given steady state. Steady state meanings, if I go at 10 a.m. also, I'll found the same number, I will found that same parameter. Let us suppose if depth is y. If I go at 10 a.m., I'll find the same depth y. If I'll go at 11 a.m., I'll find the same depth y. So what means steady state means? Steady state, if you're talking about your velocity, your discharge, everything is constant. Okay, with respect to time. So here volume is constant. And you know volume is equal to what? Velocity is constant, because parameters are constant with respect to time. So velocity is constant. If velocity is constant, you know speed is equal to distance upon time. Okay, speed is equal to distance upon time. So from here what will happen? Length, distance, I can write it as velocity into time. So length of, it has asked the length of CMFR to the length of PFR. This will be equal to velocity is constant, so they'll get cancelled out. T of CMFR to that of T of PFR. That's it. Now what is the T? 0.25 divided by K. 0.25 divided by K. And for PFR it is 0.22314. 0.22314 divided by K. How much you are getting? 1.12? Okay, fine. Then 1.12. Remember, Arun, Yamuna, everybody else, if in the question something they are not giving, like in this question K was not given. So if let us suppose MCQ question comes and there would have been one option data insufficient. So don't mark that data insufficient, because it might be possible if some values are not given, they might not be required, or they might have got cancelled at the end, like this. I asked you na K value is there, you guys said no, but I didn't say data insufficient, because I know at the end K will get cancelled out. Okay, so this you should know. Next, coming to this question, very simple. So a river has a flow of 1000 million liters per day. So discharge is given to you as 1000 mld. 5 days BOD is given to you 5 mg per liter. So 5 days BOD is given to you as 5 mg per liter. Dissolved oxygen before receiving the wastewater. Before receiving the wastewater, dissolved oxygen is given to you. So technically this will be dissolved oxygen of the river or that stream. So dissolved oxygen before receiving the wastewater discharge, that is 8 mg per liter. See, directly also they could have told you dissolved oxygen of the river, but they are writing in this way so that you tend to make mistake. For existing environmental condition, the saturation DO level, so DO saturated is given to us in the question, 10 mg per liter. Wastewater discharge, so this was the Q of river, and the Q of sewage, or you can write QW also, whatsoever you are comfortable. Sewage is 100 mld, and the BOD of sewage, here this is 5 md, this is BOD of river, and the BOD of sewage is 5 days BOD of sewage is 200 mg per liter. Now the DO level of 2 mg per liter falls at that location. Assume complete mixing. The immediate DO deficit, how will you calculate? The immediate DO deficit, guys. Immediate DO deficit. Turant, the moment when you dispose the sewage, that moment how much deficit in the dissolved oxygen you are getting. That dissolved oxygen. It is not asking about critical. It is asking you immediate. So immediate will be DO saturated minus DO mix. DO saturated they have given to us in the question 10 mg per liter. DO mix you have to calculate You know DO mix is equal to discharge of sewage, DO of sewage plus discharge of river into DO of river divided by discharge of sewage plus discharge of river. So like guys calculated discharge of sewage 100. DO is given to be how much? 2 it is was given. Na? DO level was given to you as 2 mg per liter. Discharge of river is 1000. DO is given to us as 8 mg per liter. 100 plus 1000. How much it is coming guys? Calculate how much it is coming DO mix. Now see, in this question, they have just given BOD for confusing you. There was no use of this BOD. There was no use of this BOD. So these data, it's not every time necessary that whatsoever data is given has to be used. How much it is coming guys? DO mix 200 plus 8000 divided by 1100. 7.45. Correct. Now Yamuna is in full form today. Mg per liter. This is DO mix. Just subtract it 10 minus 7.45. How much it will come? 2.54 will be the answer. Got it? This is the question. Simple question. Okay. Now, coming to question number 6. A stream with a flow rate of 5 meter cube per second. So, discharge of river only I'll take it as 5 meter cube per second. Have an ultimate BOD of 30 mg per liter. So, BOD ultimate of river is given to you as 30 mg per liter. Okay. A wastewater discharge, so obviously there is sewage whose discharge is 0.2 meter cube per second and whose 5 days BOD is given to us, not ultimate BOD. So 5 days BOD of sewage is given to us as 500 mg per liter. This joins the river at a particular location and that wastewater gets mixed. The cross-sectional area of the stream is given to us as 40 meters square. BOD reaction rate constant is given to us. It is asking how much BOD is remaining. So whenever BOD remaining, it is talked about LT is equal to L naught e to the power minus KT and it is asking at 3 kilometer downstream. Okay. So first, either K is given to us. Yes, K is given to us. How much? 0.3. Is time given to us? No. But I know time is equal to distance upon velocity. Okay. Distance is given to us. Yes, 3 kilometer. That is 3 into 10 raised to power 3 meters. Velocity. Is velocity given to us? No. But I know velocity is equal to discharge upon area. Make sure, very very important, I'll tell you both in Hindi and English. जब भी सीवेज को मिक्स करने के बाद वो बोलता है कि डाउनस्ट्रीम में कितना बीओडी होगा, जब वेस्ट वाटर सीवेज में मिक्स हो गया है, पेपर में आपको रिवर ही लिखा मिलेगा, ठीक है, पढ़ने में भी रिवर बोलेंगे, सब जगह रिवर या स्ट्रीम ही मिलेगा, बट आपको खुद कॉमन सेंस लगाना है. अगर भाई साहब एक पॉइंट पर आपने सीवेज को मिक्स कर दिया है तो डाउनस्ट्रीम में यू विल बी गेटिंग नॉट ओनली द डिस्चार्ज ऑफ रिवर, डिस्चार्ज ऑफ सीवेज भी. बोलने में, दिखने में, लिखने में एवरी टाइम दे विल बी राइटिंग डिस्चार्ज ऑफ रिवर, बट मेक श्योर डिस्चार्ज की अगर आप बात करो व्हेन यू आर टॉकिंग अबाउट इट, इट हैज बीन एडेड, the wastewater is added before only. So although everybody will say it is the discharge of river, you'll write it also same, but you should know actually this is the discharge of river plus discharge of sewage. Got it? So come on, add it. 5 meter cube per second, 0.2. You will be getting it in meters per second. How much? 0.2 plus 5 divided by 40. 0.13, right? So do it here, 0.13. How much you will be getting? How much time you are getting? You will be getting in seconds because this is in meter and this is in meter per second. For getting it into days, you have to do what? You have to divide it by 86400 for getting it in days. So you will get the answer in days. How much days it is coming? You are getting it in seconds. Convert second into days. Because here it is given 0.3 per day and E does not have any dimensions. So you have to substitute time in days. How much it is coming, guys? Faster, faster, faster. So I got this. One thing which I haven't got right now is ultimate BOD. Let me make it very much clear. This will be ultimate BOD of the mix. Is it clear? Now, when you talk about BOD ultimate mix, let's be quick, huh? 2.82 into 10 raised to power minus 4. Let me check it out how much you are getting like this. 3000 divided by... No, you are getting 0.267 only, Rahul. You did mistake, beta. 0.267. Okay. Now, BOD ultimate of mix is equal to discharge of river into BOD ultimate of river plus discharge of sewage into BOD ultimate of sewage divided by discharge of river plus discharge of sewage. Discharge of river is 5. Ultimate BOD is given to you as 30. Discharge of river stream sewage is 0.20. But BOD ultimate of sewage is not given to you. 5 days BOD is given. So with the help of 5 days BOD, first you will calculate BOD ultimate. So L naught 1 minus e to the power minus kT. Okay. So 5 days BOD is how much? I saw somewhere 500. Ultimate BOD for you have to calculate 1 minus e to the power k is 0.35. I'll write it here again. 500 L naught 1 minus e to the power minus 0.3 is the constant. Time is 5. Calculate ultimate BOD. Ultimate BOD of sewage. Calculate that. Ultimate BOD of sewage. 500 divided by 1 minus e to the power minus 0.3 into 5. How much it is coming, guys? Check it out. The moment you got this, just do it here. You will get BOD ultimate mix. So you are seeing, very simple question, but for calculating ultimate BOD of the mix, you have to do all these things. How much it is coming? 643.66 it was coming. When you substitute it here, how much you will be getting BOD ultimate mix? See, at least I'm not talking about virtual calculator, but scientific calculator, you have to be fast, right? Like Rahul, Yamuna, they are fast. Do it, keep it up. How much? Okay, now substitute it here. 53.6. You will get how much BOD will be remaining, because this formula is for remaining BOD. How much BOD will be remaining? Okay, 49.57. Got this? Same pattern of question they have asked 4 to 5 times. Okay, now 7th question. Is it visible or it is striking over my head? Let me see. Okay, so relationship, it is being given to you. I should have done it like this or what? The relationship between oxygen consumption, that is how much oxygen is consumed, and the biodegradable organic matter. See, you tell me. Very simple thing I want to ask. Is it possible that I can calculate how much organic matter is there? Of course not. Because if I talk about the general form CaHBOCNDSEPF, this is the general form, and it is not necessary that all elements have to be present. Infinite combination of organic matter is possible. So how could I know that which organic matter is getting decomposed? Instead of measuring organic matter, I measure oxygen equivalent of biodegradable organic matter. Why? Because microorganisms is using oxygen for carrying out the decomposition of organic matter. How much oxygen will be used by microorganisms? That much organic matter will be present. मतलब directly आप measure नहीं कर पा रहे थे organic matter कितना है, जो कि possible भी नहीं है, क्योंकि यार n number of combinations are possible. तो आपने बोला यार microorganisms oxygen क्यों ले रहा है? Organic matter के decomposition के लिए. तो अगर मैं पता कर लूँ कितना oxygen है, तो क्या मुझे पता चल जाएगा कितना organic matter है? बिल्कुल. 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. जितने gram equivalents oxygen के use हुए, that much gram equivalents will be for biodegradable organic matter. Got this? Now, this follows again first order kinetics. Rate of change of parameter is directly proportional to parameter. When you remove this proportionality sign, you will get a constant K. Okay? साइन आपको अपना दिमाग लगाना पड़ेगा. टाइम विथ रिस्पेक्ट टू टाइम ऑर्गेनिक मैटर इज डिक्रीजिंग, टाइम इज इंक्रीजिंग, ऑर्गेनिक मैटर इज डिक्रीजिंग, so you will put a negative sign. Okay, when you integrate this, you will come to know that BOD consumed will be L0 minus LT. So B will be the correct option. You guys can integrate it also at time t is equal to 0, or you will integrate in this manner actually. TLT minus LT. This will equal to minus K dt. So when you will integrate at t is equal to 0, the organic matter was present was ultimate. At any time t is equal to t, the organic matter present was LT. So in this way, when you will integrate, you will find BOD is equal to L0 minus LT. So the question was very simple, but it was a lengthy question. Now, a gas contained two types of suspended particles. One size was 2 micrometer and another size was 5 micrometer. Tell us which should be done. Means what procedure should be done for the removal of the particles. Come on guys, tell me fast. This I am not going to tell. Arun, Rahul, who are there, Yamuna and others are there, but they won't answer, right? Which one we'll go for? First, settling chamber followed by back filter. See, we want that the higher particles whose size is more should be removed. So first we'll go for settling chamber. Okay. Then you know that the efficiency of back filter is they can remove particles of sizes less than 1 micrometer also. So settling chamber followed by back filter. Because if you back filter means fabric filter, okay, because it has a efficiency that it can remove particles of less than 1 micrometer also. So first you want that the larger size of particles should be removed, then you will go for back filter. Okay. A, B same for which one? Okay. Next question. Come on. Do this question. Faster, 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 faster. Come on guys. Every question I am only doing. A gaseous chemical has a concentration of 41.6 micromole per meter cube. Pressure is 1 atmospheric, but temperature is not 0 degrees Celsius. Here it is 293 Kelvin. If it is 0 degrees Celsius, temperature would have been 273. But right now it is 293. So your gas constant is given to you. It is asking gas law is valid. Gas law is PV is equal to nRT. Okay. It is asking the concentration of the chemical in ppm. How will you do it? Concentration of the chemicals in ppm. So first let us calculate the volume. Volume is equal to nRT by P. Number of moles they have mentioned 41.6. For the micro they have mentioned. Na? So this will write 10 raised to power minus 6 mole per meter cube. R is given to us in the question 82.05 into 10 raised to power minus 6. Temperature is given to us as 293. Atmosphere is 1 atmosphere. Back filter 98-99% efficiency. Yes, correct. And they can remove even the smallest size of particles also. So efficiency is also high. Drawback, you should use a dry, dry pollutants. If you use wet pollutants, efficiency will not be that high. Come on, calculate this one. Come on, calculate how much it is coming. Fast. 10 raised to minus 6 will get cancelled out. How much you will get? 41.6, 82.05 into 293. Technically, here also you will get 10 raised to power. How much you are getting? Minus 6. Yes, guys, calculated. Are you getting 10 raised to power minus 6 meter cube? Yes, that means 41.6 micromole, which is given to you, of what happened here? Of gas has how much volume? Has 10 raised to power minus 6 मीटर क्यूब वॉल्यूम. करेक्ट. अगर आप वजन करते हो 41.6 माइक्रोमोल ऑफ गैस का, उसका जो वॉल्यूम निकल के आता है दैट इज 10 raised to power minus 6 मीटर क्यूब. नाउ यू नो व्हाट 1 ppm इज इक्वल टू 1 मीटर क्यूब ऑफ गैस, जो कि आपको पता है, डिवाइडेड बाय 10 raised to power 6 पार्ट्स ऑफ एयर. Now, instead of writing 1 meter cube, what you can write? What you can write, guys? What you can write? Simple है भाई, very much simple. 10 raised to power minus, common sense, 10 raised to power minus 6 मीटर क्यूब में अगर 41.6 माइक्रोमोल गैस है तो 1 मीटर क्यूब में कितनी गैस होगी? यूनिटरी मेथड. आग लगाने का खतरा बहुत रहता है. किस चीज में? अच्छा, फैब्रिक फिल्टर में. करेक्ट. सो 10 रेज टू पावर माइनस 6 मीटर क्यूब वॉल्यूम में अगर 41.6 माइक्रोमोल गैस है तो 1 मीटर क्यूब वॉल्यूम में गैस की कितना वजन होगा, कितने मोल्स होंगे? सो 41.6 इंटू 10 रेज टू पावर 6 माइक्रोमोल. सो इंस्टेड ऑफ 1 मीटर क्यूब ऑफ गैस आप ऐसे भी लिख सकते हो 41.6 इंटू 10 रेज टू पावर 6 माइक्रोमोल पर 10 रेज टू पावर 6 लिख सकते हो. 10 रेज टू पावर 6 मीटर क्यूब. और ये होता है आपका 1 ppm. सो 1 ppm की जगह व्हाट यू कैन राइट इन प्लेस ऑफ 41 पॉइंट, यहाँ पे के लिए 41.6 माइक्रोमोल पर मीटर क्यूब. सो 41.6 माइक्रोमोल पर मीटर क्यूब की जगह आप क्या लिख सकते हो? आपसे पीपीएम में पूछा ना, 1 ppm. नाउ लेट मी एक्सप्लेन यू वेरी सिंपल, बहुत ही सिंपल है. देखो 1 ppm का मतलब होता है 1 मीटर क्यूब किसी और चीज का, 10 रेज टू पावर 6 मीटर क्यूब किसी और चीज का. अब यहाँ पे कोई गैस है, गैस नेम इज नॉट बीन मेंशन, तो हमने सिर्फ गैस लिख दिया. 10 रेज टू पावर 6 मीटर क्यूब ऑफ एयर में 1 मीटर क्यूब की गैस है. ठीक है. अब अगर मैंने इस गैस का वॉल्यूम निकाला तो मुझे पता चला उसके पास 10 रेज टू पावर माइनस 6 मीटर क्यूब का वॉल्यूम है. कितने वजन है गैस का, कितने मोल्स है गैस के? 41.6 माइक्रोमोल है गैस का और उसका वजन है 10 रेज टू पावर माइनस 6 मीटर क्यूब, जो कि उसका वॉल्यूम है. अगर 10 रेज टू पावर माइनस 6 मीटर क्यूब वॉल्यूम में 41.6 माइक्रोमोल प्रेजेंट है, मोल उसका, तो 1 मीटर क्यूब में कितना प्रेजेंट होगा? 41.6 इंटू 10 रेज टू पावर 6, और एयर तो है ही, 10 रेज टू पावर 6 कैंसिल आउट हो जाएगा, आपको मिल जाएगा 41.6 माइक्रोमोल पर मीटर क्यूब. तो 1 ppm में 41.6 माइक्रोमोल पर मीटर क्यूब कंसंट्रेशन है उस गैस का. तो 41.6 तो मुझे पहले से ही दिया था, इसने मुझसे पीपीएम में पूछा था, तो 1 ppm हो जाएगा. गॉट इट? अंडरस्टूड? यमुना, अरुण, एवरीबॉडी अंडरस्टूड? दिस इज द मीनिंग ऑफ द क्वेश्चन. नाउ ये तो बहुत ही इजी क्वेश्चन है, ओनली यू शुड नो बैलेंसिंग. बैलेंसिंग आनी चाहिए. दिस क्वेश्चन इज डैम सिंपल अदर देन दैट. ओके, क्लियर? ओके. A sample of water contains an organic compound C8H16O8 is given to you, whose concentration is given to you. It is asking theoretical oxygen demand. Theoretical oxygen demand means you are doing it in pen and paper. You haven't performed any experiment. And theoretical oxygen demand, you assume that complete decomposition of organic matter has taken place. Whether it is a biodegradable organic matter, whether it is a non-biodegradable organic matter, complete decomposition of organic matter has taken place. So what you will be doing? You will be adding oxygen. Obviously, you will be getting carbon dioxide and water. But the only thing which you need to do, that in this balancing is not done. So here 8 carbon is there. What you will add it? What you will add it or what you will multiply? 8 carbon, 8 carbon. Here it is 16 hydrogen. So 16. Here 8 to the 16. How much oxygen is 8 to the 16? 8. 16 plus 8, 24. Here I have only 8. 8, 16, 8. Check it out. The moles of carbon, hydrogen and oxygen are same both on the reactants and product side. Okay. And make sure if you are 320 होगा क्या? क्या 320 होगा? इसका आंसर बोल रहे हो? किसका आंसर बोल रहे हो? Okay. So now if you talk about, you have to calculate the molecular weight of C8H16O8. Come on, Arun, everybody else calculate it. Don't read to remember the atomic weight. Gate doesn't expect you to remember it. Generally, they'll mention you the atomic weights. 16 into 1, oxygen 16. Calculate how much it is coming. 240. ओके, अब मैं आपको एक और मेथड बता देती हूँ. सी 1 मोल ऑफ C8H16O8. अच्छा हाँ, एक क्वेश्चन और आपके दिमाग में आएगा, मैम हमें पता कैसे चलेगा कि सिर्फ कार्बन डाइऑक्साइड या वाटर ही बनेगा? हाउ कम वील एबल टू नो दैट ओनली कार्बन डाइऑक्साइड एंड वाटर विल बी फॉर्म? सी if you would have taken, see, A, B, C is differing, number of moles is differing. If it would have been glucose, you know obviously what you would have got, 6CO2 plus 6H2O. So what I mean to say is, if you have carbon, hydrogen and oxygen only and they react in the presence of oxygen, you get carbon dioxide and water. हाँ, जो moles है that will be different, but you will be getting carbon dioxide and water if any other nitrogen, phosphorus is not present. If nitrogen would have been present, then ammonia also you would have got it. So अगर confusion है, पता कैसे चला कि सिर्फ carbon dioxide या water ही बना? So I have told you the answer for it. So 1 mole of C8H6O8 requires 8 moles of oxygen. So 10 raised to power minus 3 moles per liter will require how much oxygen? 8 into 10 raised to power minus 3 moles per liter of oxygen. And if you want to get the weight, you know, moles is equal to given weight divided by molecular weight. You want to get the given weight. So just multiply with the molecular weight of oxygen. O2 molecular weight is 32. Just multiply. You will get the answer in grams per liter. How much you are getting? Glucose. This one, how much you are getting? This will be the answer. Got it? Simple question for 1 marks. Environment problem seems tough. It is not tough. Practice. If you do practice on continuous basis, Yamuna, you'll be able to solve it. I'm not see this question. Very simple. They've asked for 2 marks. A 50 ml sample of industrial wastewater is taken into a silica crucible. The empty weight of the crucible is given to you. Crucible means it's like a china dish where you are putting suspended solids and everything, in which you are carrying out the experiment. Okay, so empty weight of crucible is given to you. That crucible, it might be possible since it is open, some moisture would have been there. So first, what is happening? The crucible right now here they haven't taken, but otherwise sometimes you just heat the crucible to make it moisture free. But इस question में नहीं बोला. The crucible with the sample is dried in a hot air oven at 104 degrees Celsius till a constant weight is achieved. अब आपको इसके लिए process पता होना चाहिए. If you heat a sample at 104 degrees Celsius, what do you get? Suspended solids or dissolved solids? What do you get? You get suspended solids. Got it? Now, let me tell you one more thing. यहाँ पर weight of crucible है, उस suspended solids में, ठीक है? Sample is dried, you get a constant weight 55.129. इसमें crucible में suspended solids है, जो volatile solids है वो भी है, क्योंकि वो उड़े नहीं. Volatile solids को अगर आप चाहते हो वो उड़े, तो आपको 600-650 डिग्री सेल्सियस का टेम्परेचर देना पड़ता है. Volatile solids भी है, non volatile solids भी है. Both comes under the category of suspended solids, but मैंने bifurcate करके लिख दिया आपकी जानकारी के लिए. This comes out to be 55.129 grams. Now, if Arun is asking, no, I want to know how much is volatile solids and how much is non-volatile solids. So then you have to take this 51.129 grams, put it in a muffle furnace. That is a special furnace. Why it is special? Because it can bear temperature of 600 to 650 degrees Celsius. Generally, you heat it for 1 to 3 hours. Okay. The speciality of the volatile solids, you call it as volatile solids. In the examination, they can ask you with n different names. They can tell you total volatile solids. They can tell you this as organic solids. Okay, so you should know the names of it. So it is asking how much solids is being vaporized, because when you heat it at high temperature, volatile solids will vaporize. What you will get is non-volatile solids, or you call it as inorganic solids, or you call it as fixed solids. All the synonyms you should know. So when you heat it, you will be getting, what is happening here? I checked on pen. I'll be getting weight of crucible plus non-volatile solids. Why? Because volatile solids has been vaporized. 54.783. So now it is asking you volatile solids. You can see it. Weight of crucible plus volatile solids plus non-volatile solids. Weight of crucible plus non-volatile solids. So how much will be volatile solids from here? Very easy breezy question. 55.129 minus 54.783 grams. This is in grams. And how much sample is there? 50 ml. 50 ml sample is there. So how much you will be getting? Ma'am, my gate rank is not that good, ma'am. Can I prepare for state PSC? Of course, guys, you can prepare for state PSC. अब इसको, if I want to convert grams into milligrams, first I'll know 55.129 minus 54.783. This comes out to be 0.346. So 0.346 grams. If you want to convert grams into milligrams, 10 raised to power 3. And if you want to convert milliliters into liters, you will divide by 1000. How much it will come? So from here, when you're converting milliliters into liters, so it will come out to be how much? 6920 mg per liter. You're converting gram into mg and milliliters into liters. Got it? Yamuna, Rahul, everybody got it? ग्राम को मिलीग्राम में कन्वर्ट किया, ml को liters में कन्वर्ट किया. Got it? So this is the thing. Come on, next question. This is a tick the correct statement question. The most important type of species involved in the degradation of organic matter in the case of activated sludge process based water treatment plant is chemoheterotrophs. First of all, there are two types, autotrophs and heterotrophs. Okay, so one utilizes organic carbon, another utilizes inorganic carbon. Let me tell you, when you talk about the treatment of activated sludge process, here chemoheterotrophs are being used on prominent basis. So first statement is correct. Now, the partially treated effluent, मतलब अभी भी उसमें organic matter है. Partially treated means organic matter is there from a food processing industry containing high concentration of biodegradable organic matter is discharged into a flowing river. एक river flow कर रही है और at point P पर आपने discharge कर दिया that sewage which consists of organic matter. If rate of degradation means Kr is higher as compared to Kd, rate of reaeration. No. Opposite, rate of degradation is higher. That means Kd is higher as compared to Kr. That means more oxygen is being utilized for carrying out the decomposition of organic matter. So then dissolved oxygen for the river water will be lowest at point P. Ye question, similar pattern of questions. Now you'll say, ma'am, it is a repetition. If you see disposal of sewage effluent, same pattern of question, ditto same question has been asked, but उसमें पूछा था कि maximum जो आपका dissolved oxygen river water का कहाँ पर lowest होगा, and 4 options was given. यहाँ पर उसको statement wise बना के दे दिया. That's why it is being told that try to solve PYQs 4 to 5 times. That is the reason for it. See, the moment when you dispose the sewage, you won't get the minimum dissolved oxygen. That sewage will get mixed with the river water, degradation will be carried out by the organic matter, and after a certain time you will get critical DO deficient. So it's not at point P, it is at point downstream of P, but they have written at P, so this will be wrong. A young lake characterized by low nutrient and low plant productivity is called eutrophic lake. False. Generally, it is like oligotrophic lakes. Low nutrients means low algae and all is present. If more algae is present means more productivity. More productivity you get it for eutrophic lakes, senescent lakes. Less productivity you get it for oligotrophic lakes. Okay. For an effluent sample of a sewage treatment plant, the ratio of 5 days BOD 20 degrees Celsius upon ultimate BOD is more than 1. False. Ultimate BOD will always be more than 5 days BOD. So this will be false. Okay. Going to the next question. Self preparation also. If you practice self food preparation auto. Correct. Self food preparation. Okay. A secondary clarifier means sedimentation tank, handles a total flow of 9600 meter cube per day from an aeration tank. Okay. The concentration of solids flow in the aeration tank. So aeration tank is there and the flow of solids into this aeration tank is 3000 mg per liter. The clarifier is required to thicken the solids to 12,000 mg per liter, and for that we have solid flux of 3.2 kg per meter square hour. It is asking you the surface area. Damn simple question, guys. Solve it. It is asking you to calculate the surface area. Come on. Everybody. Every time asking to me. When you will do it? I'll draw it also. What? Aeration tank, secondary sedimentation tank. Obviously, a part will recirculate, a part will be wasted, and a part will be effluent. Now, what it is asking you in the question, it is asking you to calculate the surface area. How will you calculate the surface area? How will you calculate the surface area, guys? How will you calculate the surface area? Faster. Okay. First of all, I need to see how much solid, how much suspended solid, how much microorganisms is getting loaded to the secondary sedimentation tank. How much solids is getting loaded? So solid loading to SST. That will be discharge. Q0 will be there. Q0 is coming. Recirculated will be coming. So here Q0 plus QR. So Q0 is coming. QR is coming. This much is the discharge which is there. Then what is there? X microorganisms. This much amount is getting loaded. That means how much is there? How much is there? Q0 plus QR is given to me. Total, it is written, handles a total flow. That means discharge of sewage is there and recirculated discharge is there. 9600 meter cube per day. Solids concentration is given to you as 3000. Yes, it is given to me as 3000 mg per liter. So converted, guys, meter cube converted into liters and mg converted into kg. So from here you will get the solids value in kg per day. How much you are getting kg per day? Let me check it out. 9600 into 3. You get it around, how much you are getting it here? You are getting it around 28800. This you are getting it. Yes? Yes? Have you guys checked it? It is 9600, right? I think they have mentioned it wrong. This might be 6900 or what? Just check it out. This is 2021 question. I guess it will be 6900 as far as I remember. 3000 minus 3. Okay, let's check it out whether it is 9600. We are doing it considering it as 9600. Let's 9600, no? No, I'm talking about the official question one. This is the solid loading rate which is given to us. Now check it out. If you don't know the basics, go with the units. कितना solid आ रहा है? 28,800. आपको solid flux कितना दिया? 3.2. So अगर मैं 28800 kg per day, 1 day is equal to 24 hours. इसको divide कर दूं 3.2 kg per meter square per hour. Kg per hour will get cancelled out. I will directly get the area in meter square. So let's do it out. How much you are getting? 375 meters. Directly area आगे बताओ. This is not even for 2 marks. This is a 1 marks question, guys. Integer में बताना, integer में आ भी गया. So how much solid is being loaded? Obviously discharge of sewage plus recirculated discharge. Solid means suspended solids. Suspended solids mean microorganisms. So इतना solid गया था, 1 लीटर में अगर 3000 mg का सॉलिड है तो 9600 मीटर क्यूब पर डे में कितना सॉलिड्स होगा? यू मल्टीप्लाइड इट, दैट्स इट. गॉट इट? ओके. क्वेश्चन नंबर 18. अब ये इतना बड़ा क्वेश्चन है, कुछ नहीं है इस क्वेश्चन. अ ग्रिड चेंबर रेक्टेंगुलर क्रॉस सेक्शन है जिसको डिजाइन किया गया. द मेन रीजन फॉर डिजाइनिंग दिस ग्रिड चेंबर टू रिमूव पार्टिकल्स whose size is 0.25 mm, whose specific gravity is 2.70. Settling velocity of the particles is 2.5 centimeter per second. The width of the chamber is given to you as 0.50 meter. Peak discharge is given to you as 9720 meter cube per day. Depth is given to you as 0.75 meter. Flow through velocity is given to you as 0.3 meter, has to be maintained. The minimum length of the chamber it is asking. How will you calculate the length, guys? How will you calculate the length? Length. How will you calculate the length? You know, if I know L into B into H is equal to volume. Okay. If I do volume divided by B into H, I will get the length. Yes. Can I able to calculate it? Can I able to calculate it, guys? Or discharge is equal to area into velocity. Discharge I know. Remember, settling velocity. Discharge I know. Settling velocity is given to this question. Maximum things which is given in the question is just for confusing you. That is not at all required. Now check it out. Discharge is required 9720 meter cube per day. Settling velocity is how much? Settling velocity is how much? 2.5 centimeter per second. So 2.5 centimeter per second. So you can write it as 10 raised to power minus 2 meter per second. Okay. Now convert days into seconds. So 9720 divided by 86400 seconds into 2.5 into 10 raised to power minus 2. So from here you will get the area directly. Eight six four double zero. This will become 4.5 meters square area. I know area is equal to length into width. This is the area. So from here I'll get it area by width. 4.5 divided by width is 0.5. How much I'm getting? 9 meter. 9 meter will be the length. Got it? Understood? Simple question for 1 marks. Discharge is equal to area into velocity. Divide by width. That's simple question. Okay. Now this question. Diagram is also given to you in the question. So an activated sludge process is designed for a secondary treatment of 7500 meter cube per day of wastewater. Okay. Ultimate BOD of the influent which enters. So BOD is given to you as how much? 200 mg per liter. Treated effluent after secondary clarifier is required to have an ultimate BOD. So here the ultimate BOD is 20 mg per liter. Okay. Mixed liquor volatile suspended solids MLVSS X value is given to us 3000 mg per liter and underflow volume is given to us as 12,000 mg per liter. Now in the question hydraulic retention time is given to us 0.2 per day, 0.2 day and mean cell residence time means sludge age is given to you. Okay, it is asking us to calculate underflow volume. How will you do it, guys? It is asking to calculate underflow volume. That means it is asking us to calculate QW. How will you calculate QW? How will you calculate QW? You know, theta C is equal to Vx. Here, Xc is also given to us, right? So it is QW XU plus Q0 minus QW XC. Is it? Is it? Now, this is the BOD value which is given to us. XC is not given to us. How much is the suspended solids going out is not given to us. That means XC is 0. So what will become? This will become 0 because no suspended solids is given what is going out. Theta C is given to us. Sludge age is given to us 10 days. Volume is not given to us directly. You know, volume is equal to discharge into time. Discharge is 7500 meter cube per day. Time is how much? Time. Hydraulic retention time 0.2 days. So this will be 7500 into 0.2. That means 1500 meter cube is the volume. 1500 meter cube. X is 3000. QW you have to calculate. XU is given to you in the question. How much? 12,000. Okay. So from here, calculate QW. That's simple. So from here, when you will calculate QW, initially you will get it what? You will directly get it in meter cube per day. How much you will get? You will get it as 37.5 meter cube per day. 37.5 meter cube. This will be the QW. Okay. Very simple question. Okay. Now moving to question number 60. The liquid form of particulate air pollutant. Liquid form of particulate air pollutant. Come on guys. Liquid form of particulate air pollutant. What is the liquid form? Mist and liquid forms. Particulate matters which are there, finely suspended solids which are there. What is the particulate air pollutant? Come on, tell me fast. What are that? Liquid forms of particulate matters are mist and spray. Mist and spray. Correct. Okay. Now talking about, this is a very good question. Huh? Very good question. Remember, whenever you are solve this question. This is a very good question. Okay. A baghouse filter has to treat 12 meter cube per second of wastewater, and the baghouse is to be divided. The baghouse is there and it is divided 1, 2, 3, 4, 5. 5 equal sections are there. Okay. But out of this, 4 are operating. 4 are being operating. 1 is being kept as standby. In case if one of them fails because of any reason, maintenance and all, that one standby is being used. So currently 4 are functioning. Now air to cloth ratio is given to you as 6 meter cube per minute meter square. That means they have given you as velocity, which is 6 meter per minute. Okay. Now it is asking you what is the total number of bags which is required. How will you calculate this? Can I calculate area? I know the discharge, I know the velocity. So I know area is equal to discharge by velocity. Discharge given to us as 12 meter cube per second. Velocity is 6 meter per minute. So 12, 6, converting minute into seconds. So this will go up. 6, 120 it is coming. 120 meter square is the area. Now, what is the area of one bag? What is the area of one bag? Area of, this is the total area. What is the area of one filter bag? So area of one filter bag is pi dl. Pi. Dia is given to us as how much? 0.32 centimeter, 0.32. Length is 5 meters. How much it will come? 5.026 meters square. This will be the area of one filter bag. Now listen to me. Out of this 120 meters square, this is the total area. One thing which you guys will often make mistake is, area of one filter, you will write it as 120 divided by 5, which will be wrong. Because currently, सिर्फ 4 filter bags function कर रहे हैं. Okay, सिर्फ 4 filter bags are functioning. So what you will write it here? What you will write it here, guys? Cloth area per operating section. Per operating section. Total area is 120. But the numbers which are operating is 4 only. So 30 meter square is there for per section. For per section. So how many sections are there, guys? How many sections are there? 5 sections are there, but currently 4 are being operating. 4 are being operating. So how much filter bags we should require? Number of filter bags should be how much? Total 30 meter square divided by area of one filter bag 5.026. 5.026. बिकॉज एक क्लोथ एरिया से आपने बोला कि जो क्लोथ्स बनाए जा रहे हैं, ठीक है, तो उसमें आपने 5 इक्वल क्लॉथ्स को बात किया, बट 4 ही से काम चल रहा है, एक को आपने रखा है स्टैंड बाय में। अब 4 से अगर बात करूं तो हर को कितना ऑपरेटिंग मिल रहा है, 30 मीटर स्क्वायर का एरिया मिल रहा है। इससे कितने फिल्टर बैग्स बन सकते हैं, 30 मीटर स्क्वायर, और एक फिल्टर 30 फिल्टर स्क्वायर एक को मिल रहा है एक सेक्शन को, और एक फिल्टर बैग बनने के लिए 5.026 मीटर स्क्वायर का एरिया चाहिए। तो कितने फिल्टर बैग्स हो जाएंगे, 30 divided by 5.026, this will come out to be 5.96। तो 5.96 को मैं क्या ले सकती हूँ, 6 फिल्टर बैग्स। ठीक है, 6 फिल्टर बैग्स चाहिए, प्लस एक आपने किसमें रखा है, एक आपने किसमें रखा है, 6 फिल्टर बैग से आपको क्या चाहिए, आपको चाहिए, ठीक है, बट इसके अलावा एक आपने किसमें रखा है, स्टैंड बाय में रखा है। सो टोटल नंबर ऑफ फिल्टर बैग्स कितने चाहिए होंगे गाइस, टोटल नंबर ऑफ फिल्टर बैग्स कितने चाहिए होंगे, कॉमन गाइस, 30/5 नहीं करना, ये 30/5, अच्छा 5.026 बोल रहे हो क्या, कितने चाहिए आपको, टोटल नंबर ऑफ बैग्स की अगर मैं बात करूं तो आपको ऑपरेटिंग जो चल रहे हैं प्लस नॉन ऑपरेटिंग दोनों चाहिए होंगे। तो कितने चाहिए होंगे भाई साहब, कितने चाहिए होंगे, एक 4 6 इंटू 4, ठीक है 24 है, प्लस प्लस एक सेक्शन में 6 फिल्टर बैग और है, 6 पर सेक्शन, ठीक है, 4 काम कर रहे हैं और एक को आपने रखा है स्टैंड बाय। सो 6 6 4 24, 24 प्लस 6 30 फिल्टर बैग्स टोटल चाहिए, 30 बैग्स, करेक्ट, गॉट इट। चलो नेक्स्ट क्वेश्चन। Volatile organic compound act as one of the precursors to the formation of photochemical smog in the presence of sunlight। ठीक है, जब भी आप अगर बात करो 30 बैग्स किसने बताया था मुझे, यमुना ने, करेक्ट करेक्ट यमुना, ओके। सबसे पहले स्मॉग आप बात करो तो इसको एक और नाम है, इनकेस दे विल आस्क यू एनी टाइम, लॉस एंजलिस टाइप स्मॉग, बिकॉज फर्स्ट टाइम ये लॉस एंजलिस में पाया गया था। वोलेटाइल ऑर्गेनिक कंपाउंड्स, अब ये वोलेटाइल ऑर्गेनिक कंपाउंड्स की बात करूं तो स्मोक और फॉग एक्चुअली बनता कैसे है, इसमें सनलाइट होते हैं, इसमें नाइट्रोजन ऑक्साइड्स होते हैं, इन दिस वोलेटाइल ऑर्गेनिक कंपाउंड्स आर प्रेजेंट व्हिच लीड्स टू द फॉर्मेशन ऑफ फोटोकेमिकल स्मॉग। नाउ ऑब्वियसली फोटोकेमिकल स्मॉग बनता ही कब होगा, इन द प्रेजेंस ऑफ सनलाइट, तो पहला स्टेटमेंट सही है। Long-term exposure to the increased level of photochemical smog becomes a cause of chest contractions and irritations of the mucous membrane। बिल्कुल सही बात है। If photochemical smog, because in this nitrogen oxides is there, sulnite is there, volatile organic compounds is there. So continuously, if exposure is done, obviously there will be irritations of mucous membrane, everything will be there. And this happens during the time of sunlight. So in the times of afternoon, this photochemical smog is more prominent. This is also correct. Increased level of volatile organic compound in the indoor environment will result in the formation of photochemical smog, which is a cause of cardiovascular diseases. That is also correct. अगर volatile organic compounds की मात्रा इंडोर एनवायरनमेंट में, अगर आप घर के अंदर रह रहे हो, बढ़ते जा रही है, ठीक है, तो इससे भी आपको कार्डियोवैस्कुलर डिजीजेस हो सकती है, ये बिल्कुल सही बात है, ठीक है। अब increased level of carbon monoxide in the indoor environment result in the formation of carboxyhemoglobin, and the long term exposure becomes a cause of cardiovascular diseases। ये सही है, ये सही है, ये भी बात सही है, क्योंकि अगर कार्बन लॉन्ग टाइम प्रेजेंट है, आपको पता है कार्बन की एफिनिटी हीमोग्लोबिन के लिए ज्यादा है, तो ये ऑक्सीजन को हटाने लगती है और क्या बात करने लगती है, ये कार्बोक्सी हीमोग्लोबिन फॉर्म कर लेती है, तो ये बात सही है। तो फिर मैम ये कैसे सही हुई, नहीं, देखो दोनों स्टेटमेंट सेम ही लग रहा है, बट यहाँ पर अगर मैं बात करूं तो ये बोल रहा है कि भाई कार्बन मोनोऑक्साइड अगर प्रेजेंट है तो वो कार्बोक्सी हीमोग्लोबिन बना लेगा, जो कि बिल्कुल सही बात है, ठीक है। और अगर आपकी बॉडी में कार्बोक्सी हीमोग्लोबिन बनता गया, कार्डियोवास्कुलर डिजीज तो होगी और इसके बाद डेथ भी हो जाएगी, ठीक है, इसके बाद डेथ भी हो जाएगी। इंडोर एनवायरनमेंट में जनरली फोटोकेमिकल स्मॉग उतना ज्यादा प्रोमिनेंट नहीं बोलते, क्योंकि भाई अगर आपको फोटोकेमिकल स्मॉग करना है तो उसके लिए क्या होना चाहिए, सनलाइट होना चाहिए, ठीक है, तो ये जनरली आपको आफ्टरनून फेज में देखने को मिलता है, ठीक है, ये सबसे पहले लॉस एंजलिस में 1950s के टाइम में देखने मिला था, इसलिए इसको लॉस एंजलिस टाइप स्मॉग भी बोला जाता है। गॉट इट? हाँ, सी रॉन्ग है, वही मैं बोल रही हूँ यमुना, सी रॉन्ग है। पहले राइट बोलने दिया करो यार, तुम पहले ही आंसर बता देते हो। पहले राइट बोलूंगी फिर बताऊंगी नहीं 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 ये नहीं हो सकता, पहले ही आंसर बोल दिया, चलो कोई बात नहीं। ओके, नेक्स्ट क्वेश्चन। विच ऑफ द फॉलोइंग स्टेटमेंट्स इज आर करेक्ट? ये आपका एमएसक्यू क्वेश्चन भी हो जाएगा। कैसे? फॉर अ वेस्ट वाटर कमिंग फ्रॉम अ वुड पल्पिंग इंडस्ट्री, केमिकल ऑक्सीजन डिमांड एंड 5-day बायोकेमिकल ऑक्सीजन डिमांड वे डिटरमाइंड। फॉर दिस वेस्ट वाटर विच ऑफ द फॉलोइंग स्टेटमेंट्स आर करेक्ट? आपको पता है chemical oxygen demand carries out the decomposition of biodegradable and non-biodegradable organic matter. BOD carries out the decomposition of only biodegradable organic matter. So obviously COD किसी भी कंडीशन में BOD से ज्यादा ही होगा, और BOD तो वैसे भी BOD 5 days से ज्यादा ही होगा, BOD अल्टीमेट। तो पहला स्टेटमेंट करेक्ट है। किसी भी कंडीशन में एट मैक्स इफ नॉन बायोडिग्रेडेबल ऑर्गेनिक मैटर इज नॉट देयर, COD कैन बी इक्वल टू BOD अल्टीमेट when non biodegradable is absent, but कभी भी COD BOD 5 के इक्वल नहीं हो सकता। तो बी स्टेटमेंट इज ऑल्सो करेक्ट। अच्छा, अभी बोला था क्या? मैंने देखा नहीं। ओके, नाउ दिस क्वेश्चन ना हलवा क्वेश्चन है, वो भी 2 मार्क्स के लिए। A 2% sewage sample is there was incubated. 2% sewage sample मतलब 2 ml का सीवेज है, 98 ml is distilled water, was incubated for 3 days at 27 degrees Celsius. After 3 days, when you took out the sample, you found that dissolved oxygen which is being depleted or utilized or consumed is 10 mg per liter. It is asking you to calculate ultimate BOD. So BOD of 3 days at 20 degrees Celsius is equal to depletion of dissolved oxygen into dilution factor. How much oxygen is depleted? 10 mg per liter. And what is the dilution factor? 100 by 2. Because whenever x% is given, so dilution factor is 100 by x percentage. So from here, this will come out to be 500 mg per liter. This will be 3 days BOD. But in the question, it is asking us to calculate ultimate BOD. So what will be the ultimate BOD, guys? K is given to us 0.23, days 3. Come on, 500. How much it is coming? How much it is coming? Anybody solved it? सॉल्व करो इसको, कितना आ रहा है? अब ऐसे बहुत एब्सर्ड से फिगर आएगा, आपको डाउट होने लगेगा अपने कैलकुलेशंस पे। सो 1003 ही आप मार्क कर दोगे। Got it? This will be the ultimate. Now, come on. So we have how many questions more left? These 2 are there. Okay. Fine. A sewage treatment plant receives sewage at a flow rate of 5000 meter cube per day. तो एक प्लांट में कितना सीवेज आ रहा है? 5000 मीटर क्यूब पर डे से आ रहा है। सस्पेंडेड सॉलिड्स कंसेंट्रेशन, दिस इज द प्राइमरी सेडिमेंटेशन टैंक बना देती हूँ पहले। Suspended solids concentration is 200 mg per liter. Primary clarifier means primary sedimentation tank में जा रहा है. This is suspended solids, total suspended solids. After the primary treatment, the concentration is the sewage is reduced by 60%. मतलब efficiency of primary sedimentation tank is 60%. मतलब जो भी solids जा रहे हैं उसके 60% will get settled down. Okay, so कितना solid बाहर जाएगा? 40% बाहर जाएगा. The sludge from the primary clarifier. What is sludge? It is a mixture of solid and water. Okay. Now, how much sludge concentration is there? 2% solid concentration is there. फिर यहाँ पे जो sludge बनेगी, we took it to gravity thickening. Gravity thickening का मेन काम है कि moisture content को कम किया जाए, पानी को कम किया जाए, solids को बढ़ाया जाए. So sludge को gravity thickening में किया, पहले 2% sludge थी, now it became to 6%. Okay, आपको बताना है कितना वॉल्यूम है thickened sludge. How much is the volume of thickened sludge? ये आपको कैलकुलेट करना है. स्लज बनी क्यों? सॉलिड्स के कारण. तो तो पहले we have to calculate how much solids has settled down, because sludge is formed due to the formation of solids which have settled down. So first calculate how much solid is being formed. Okay, so here if 1 meter cube में 5000 मीटर क्यूब पर डे सॉलिड्स है और 1 लीटर में 200 mg का सॉलिड है, सो 5000 मीटर क्यूब में कितना सॉलिड्स होगा? कन्वर्ट मीटर क्यूब इनटू लीटर and convert mg into kg. How much you are getting? 5000 into 200, 3. This will come out to be 1000 kg per day. This much is the solids which is getting deposited. This much is the solids which is getting deposited. Now what we will do? This 1000 kg per day solids is basically entering into the primary sedimentation tank. Out of this 1000 kg per day of solids, what is happening? 60% is the efficiency. So out of this, 60% will settle in the primary sedimentation tank. So solids, suspended solids settling in primary sedimentation tank. This will be how much? 1000 into 60%. That means 600 kg per day is the solids which is settling down. Now how will we proceed? Come on guys. Now how we will proceed? Anybody? I want the answer. Now check it out. I'll add one slide to it. Otherwise space is not there. Just a minute, I'll add it up. Fine. Sorted. Okay. Now 2% का मतलब आपको पता है 2% सॉलिड कंसंट्रेशन का मतलब होता है 2% सॉलिड कंसंट्रेशन का मतलब होता है 2% सॉलिड कंसंट्रेशन मींस 2 kg सॉलिड में जब आप 98 kg पानी मिलाओगे तो 100 kg का स्लज बनेगा. दिस इज द मीनिंग ऑफ इट. तो अगर सॉलिड कितना है 600 kg पर डे का सॉलिड है तो बताओ कितना स्लज बनेगा? 600 into 100 divided by 2. इतना स्लज बनेगा. करेक्ट. कैलकुलेट हाउ मच स्लज विल बी फॉर्म. ये तो 2 3 3 2 3 4 इतना kg पर डे का स्लज बनेगा इनिशियली. ठीक है. अब जब आपने इसकी थिकनिंग की, क्योंकि क्वेश्चन में लिखा है ना आपने इसकी थिकनिंग की, किसी का आंसर नहीं आया अभी तक. चलो, तो अगर आपने जब थिकनिंग की तो कितना आपका स्लज रहेगा? 6%. मतलब अब 6 kg सॉलिड होगा, 94 kg पानी होगा, तो 100 kg का स्लज बनेगा. ठीक है. तो 600 kg सॉलिड का कितना स्लज बनेगा? 600 into 100 divided by 6. तो यहां से तो ये कट जाएगा. 6 6 1 2 3 4 इतना kg पर डे का आपका क्या बनेगा? स्लज बनेगा. तो उसने आपसे पूछ रहा है कि डेली वॉल्यूम बताओ थिकेंड स्लज का. तो कितना बन रहा है भाई साहब? 1 2 3 4 इतना थिकेंड स्लज बन रहा है. बट ये मास है. क्वेश्चन में वो आपसे वॉल्यूम पूछ रहा है. वॉल्यूम होता है मास बाय डेंसिटी. हाउ मच इज थिकेंड स्लज? 1 2 3 4 kg पर डे. दिस इज द मास. डेंसिटी विल बी हाउ मच? डेंसिटी इज इट गिवन टू अस इन द क्वेश्चन? मैंने कहीं तो देखा था डेंसिटी दी थी. डेंसिटी 1000 kg पर मीटर क्यूब. कितना आ जाएगा? 10 मीटर क्यूब पर डे. इसकी तो जरूरत नहीं थी, ये तो मैंने आपको बताया पहले कितना बन रहा था और ग्रेविटी थिकनिंग के बाद कितना बन रहा है. बिकॉज इफ इन द क्वेश्चन इट इज आस्किंग यू हाउ मच इज बीइंग प्रोड्यूस्ड, ओके, कितना बन रहा है, तो उसलिए मैंने आपको बता दिया. ये गॉट इट. पहले कितना स्लज बन रहा था? बिकॉज स्लज को डिस्पोज करना पड़ता है. तो हम चाहते हैं भाई साहब कि जितना हो सके सॉलिड कंटेंट शुड बी मोर, मॉइस्चर कंटेंट शुड बी लेस. दैट इज द रीजन वी गो फॉर ग्रेविटी थिकनिंग. तो आपसे पूछा है जब थिकनिंग हुई, जब व्हेन यू हैव पुट इट इनटू ग्रेविटी थिकनिंग, उसके बाद कितना स्लज बना? तो उसके बाद 1000 kg का स्लज बना. पर उससे आपसे मास में नहीं पूछ रहा, वो वॉल्यूम में पूछ रहा है. तो डिवाइडेड बाय डेंसिटी. गॉट इट. सो 10 विल बी द आंसर. ओके, नाउ दिस क्वेश्चन. आपको सैंपल दिया है. एक सैंपल है एयर का, SO2 का सैंपल है. प्रेशर इज गिवन टू एज 1 एटमॉस्फेयर. टेम्परेचर इज 25 डिग्री सेल्सियस, इसको कैल्विन में कन्वर्ट करना है, सो 273. So 25 plus 273. This will be 298 Kelvin. Okay. Now it is asking you the concentration. You have to report it in terms of microgram per meter cube. एक बहुत ही ready-made formula है. If you want the concentration in microgram per meter cube, ये specifically if you are preparing for any other examination, ये बहुत ही easy method है. तो उसका concentration ppm में into molecular weight into 1000 divided by volume of gas. बेस्ट. कंसेंट्रेशन पीपीएम में आपको दे रखा है 0.04 ppm. सल्फर डाइऑक्साइड का वेट की अगर मैं बात करूं, सल्फर इज 32, ऑक्सीजन इज 16, so 32 plus 32 is 64. So molecular weight will become how much? 64, 10 raised to power 3. Volume अगर standard temperature pressure condition, then it would have been 22.4 liters. But right now वॉल्यूम के लिए आपको क्या दिया है? वॉल्यूम इज नॉट स्टैंडर्ड टेम्परेचर प्रेशर बिकॉज टेम्परेचर चेंज हो गया. सो यू विल गो बाय द फॉर्मूला P1 V1 T1 इज इक्वल टू P2 V2 T2. प्रेशर 1 एटमॉस्फेयर दोनों में ही है. वॉल्यूम 22.4 लीटर्स होता if temperature would have been 273 Kelvin. Right now the temperature is 298 Kelvin. So what will be the volume? So calculate the volume. 298 divided by 273, 22.4. How much volume you are getting? I am getting 22.4, 24.45. Substitute it here. You will get the concentration. How much you are getting the concentration? 104.697. So I'll write it as 105 microgram per meter cube because in the question it is asking me to round off to the nearest integer. So I'll write 105. Got it? So this will be the answer. Okay? Say yes or no, guys, at least. Got this? Okay. So guys, this solid waste management question, I gave you 2 questions for homework. Do you want me to solve it or you will try again? Reply everybody. Do you want me to solve it or you will do it again? You want, I can solve it or you can take time and do it. Tell me fast, fast, fast. 2 questions were there of homework. 2023 questions already we have discussed. I'll share you the link in the comment section. You can go from here. Check it out from there. And the system is hanged now. What happened? Okay. Okay, then we'll do it. Fine. Do these 2 questions. Then also I'll tell you these 2 questions. But first try it yourself. And I wanted to share with you the dates. Right now I am taking it. Tomorrow will be our at a single stretch we'll be completing hydrology and irrigation tomorrow. Okay, tomorrow I guess we should start early, somewhere around 8 or 8:30. Otherwise it becomes late, right? So we'll start it at 8:30. I'll let you know by tomorrow. You can join my Telegram group for that. For our upcoming class at what time we'll be having. Civil by Richa Gupta, and let's do it at 8:30 tomorrow so that we can finish it off early. Okay, so tomorrow at a single stretch we'll complete hydrology and irrigation. Okay, same timing. And if in case you have any doubt, do let me know. Till then, take care of yourself, guys. Scholarship test if you're preparing for, link is in the description. And for if you haven't subscribed the channel, do subscribe it. Thank you, everybody.